Okay. Dear students, last class we have discussed about a source transformation. Okay. So there are some other aspects associated with source transformation. We will learn about them today. Okay. We will learn about those aspects in this class. See, the main objective of source transformation is to make the circuit simple and direct for the purpose of circuit analysis. Okay, what we have seen it in our last class? So this is a symbolic representation of ideal source, and this indicates ideal current source. Vs is a source voltage and Is is a source current. Okay, see, these two symbols represents ideal voltage source. So next two figures indicates a practical voltage source. Ideal source, there is ideal voltage source, there is no series resistance in series. In case of current source, there is no parallel resistance across ideal source, right? Here, if a small resistance exists in series with a voltage source, the resulting symbol is known as practical voltage source. Similarly, if a large resistance appears across a current source, the resulting symbol represents the practical current source. This is practical current source. Right. So in the last class, we have seen that voltage source can be transferred into current source and current source can be transferred into voltage source. That is, vice versa is possible. See, now I will elaborate this explanation with respect to one small example. Consider a practical voltage source as shown in a figure is having a series resistance of 5 ohm and source voltage of say 25 volt. This is connected across a load that is of say 2 ohm. Load is connected across AB. Okay. See, this source is delivering a current in a upward direction. Okay, positive inside the battery, this symbol represents. Similarly, I am evaluating current through 2 ohm resistor by applying a Kirchhoff's voltage law. Accordingly, that is, first we need to evaluate I. I is equal to 25 divided by 5 plus 2. 5 plus 2. 5 plus 2 is a 7 ohm resistance. Okay. That is 25 by 7. Answer is it is nearly 3.6 ampere. Correct? This is a current. See, same answer. I'll get it by transferring this practical voltage source into current source. Okay? See, what's the output current of this current source? It is delivering a current in upward direction. Thus, I am taking this direction in upward only. Then what's the I equal to? By source transformation method, I is equal to source voltage divided by internal series resistance, that is 5 ohm. Okay. So the answer is 5 ampere. Right? And I'll be connecting the series resistance across a current source. This is 5 ohm. Okay. Across a terminal AB, there was a resistance in voltage source. Same resistance, I am putting it here only. Okay. What's the resulting circuit now? A current source of output current 5 ampere. The resistance which was there in a parallel with a series in a voltage source, putting it in a parallel, same resistance, right? Okay, I'll reconnect the load as it is, that is of 2 ohm across AB. See here, this voltage source has been transferred to current source, and I am reconnecting a load resistance 2 ohm as it is over here, right? See, this is a current, source current, right? So I need to evaluate a current IL. Okay. Now, which rule I am going to apply it here? Here I will be applying current division rule. Current division rule to evaluate a current IL. Thus, IL equal to, what's the expression? Source current into resistance from opposite branch, that is 5, divided by summation of resistors connected in parallel, that is 5 plus 2. That will be equal to, IS means 5 into 5 divided by 5 plus 2. Answer is 25 divided by 7. That will be equal to same nearly 3.6 ampere. Okay. So this example illustrates that voltage source can be transferred to current source. Similarly, I'll get the same answer by converting this current source into voltage source by applying a source transformation. What I am going to do it here is, I'll be taking this current source. Okay. By rule of transformation, that is current source of 5 ampere connected with a 5 ohm parallel resistor. Okay. Then I'll put that 5 ohm resistor here and I'll transfer this current source into voltage source. That is, current source is multiplied with shunt resistor, that will be 25. Okay. Like that only. Same. This current source is transferred back to voltage source. Same only. Okay. I again reconnect our resistor of 2 ohm. Right. So this example demonstrates that voltage source can be transferred to current source, and vice versa. Current source can be transferred to voltage source. Right. So is it clear? Okay.